Yes.
Okay. Now, afternoon, everybody. And as Mr. Gone said in the last session, that is, and I don't have to repeat it here, but in short, as he has said, these sessions or these class sessions are merely to help you prepare for the coming examination, that is special examination. And therefore, we will focus mostly on what? On those exam type questions. And but because we are not just trying to help you memorize that whatever, I will try to give you a background for each and every topic. And please make sure that you are not left behind. Therefore, I will try to open this. And please feel free. You can interject me at any time if you feel like what you are not, something is not clear to you, then I will be forced to go back, or I will be able to go back and revise everything. If there is no question, then we can just simply shoot straight into it, get started. Everything is okay. Now, this is, I can just simply read it for you. This is a continuation of the derivative. But now what Mr. Gone did was what? He was looking at what? The derivative of a function that has got two variables. That it was y and x. Whether that y was it was alone on the one side, that is y x explicitly represented in terms of x, or it was implicitly, it shouldn't make any difference. But now what we are going to do here is not to look at the derivative of functions which are in terms of only two variables, x and y. We are going to look at the functions or multivariable functions like this one. Let me just give you an example here where we have got z equal to, but it's not only y equal to, let me just start here. It's not only y equal to x. Now, because this one is just what? It's just two variables. It's y in terms of x. But now here we're going to take it further. Look at what we call multivariable functions, where we do not only have y and x, but maybe y, x, and something else, y, x, and z, or y, x, and w, so on and so forth. But before we look at that, we are going to look at one of the applications of a function which is in terms of only two variables. That is y and x, before multivariable functions. Let us look at this one. Now, but before, don't forget this notation. It is dy dx. And this dy dx, we are differentiating here a two variable functions, where x is like an independent variable and y is a dependent variable. We can say y equal to x squared plus 3x by and whatever. Now, this notation here, dy dx, it is d by dx of y. In other words, if you are asked to find this, all what you need to do is what? You insert this guy. That is this, dy dx on both sides of your equation. Like what we have here, y equal to this one. Now you are asked to find dy. You are asked to find dy dx. All what we need to do is insert this. That is, insert d by dx on both sides of the equation. That is on the left side and on the right side. Now the left side then becomes dy dx. And the right side then becomes, we are differentiating a function which is given in terms of x. We are differentiating it with respect to the very same variable x. And then there, you just have to use those standard differential rules now. Now you differentiate the first term, which will be 2x. Then you differentiate the second term, 3x. That is, it will be d by dx of 3x. And because 3 is not dependent on x, then you can take it outside. Then this becomes 2x plus, you take the 3 outside, then it will be 3 d by d of x. And the derivative of x with respect to x, it is just 1. Therefore, the answer here, it will just simply be P3. But now, why are we studying so far? Is because of what? I want us to be together, understand what we mean by d by dx, or where does it come from, this notation dy dx. In our case here, and please, you can just stop me at any time. Now, in our application here, they say a projectile is fired, that is vertically. And now they say the motion of the projectile is given by these parametric equations. I don't have to go back to say what are parametric equations. But now these are the two parametric equations that will govern the movement of this when going up and even going down. What are those two equations? One is x equal to 2 theta multiplied by e exponent theta. And another equation is y equal to theta squared multiplied by e exponent 2 theta. And what is the question? What is the question, or what are the questions? The first question is, you are asked to find the velocity. Then you ask yourself, what is the velocity? Velocity is obviously what? Is the derivative of whatever. And because these two equations, they describe the motion, then that is why now we will call it just velocity, not the ordinary differentiation. Remember, velocity is just simply the derivative. But if the equation describe the motion of something, or if the equation is the displacement, then it's got a special name. Then we call it the velocity. The velocity here, it will be dy dx. And the acceleration, we all know it, is the second derivative. That is, the acceleration is the derivative of the velocity. Therefore, the acceleration notationally now, it will now be d by dx of dy dx, which is d by d is d squared, then you put y, and dx by dx, it will then be dx squared. Now, coming back here, we have said dy, this notation, dy dx, is where we are differentiating an equation y, which is given in terms of x. These two variables, y and x. But as you can see in these two equations, there is no one that is in terms of y and x. The first one is in terms of x and theta. And the second equation is in terms of y and theta. Now the question is, where are we going to get the notation dy dx then? Now, this is what we're going to do. You just have to derive whatever you can from each of the equation. This is x in terms of theta. Therefore, what do? Then you just write d by d theta on both sides. Because we have said y in terms of x, then you differentiate with respect to x. That is the denominator, x.
Mr. Silwane?
Yes?
There's a hand.
There's a hand. Yes, yes. You can just unmute yourself and ask a question. I can't hear you. Can anybody here unmute yourself?
No, the person who has raised the hand up is muted, so we cannot hear him or her.
And we cannot even call him or her by the name because it looks like it's just written a guest.
Yeah, it's an unknown user. Can you please unmute yourself and speak?
I am battling to see your screen.
Are you using a phone or a laptop?
I'm using the phone.
Come again?
I'm using the phone. I'm battling to see.
Yeah, this phone has got a small screen, so we are able to see what is on the board there. I would think that you need to log in with a computer or a laptop, which has got a bigger screen. Or otherwise, then you will listen to the recording after he finishes, because there is no way in which we can do anything about your screen.
I'm really sorry, man. Okay. As I was saying, dy dx. This is when we have got a function like y equal to f of x, like this. Or it can be implicitly or it can be explicitly. It doesn't matter. You can put your hand down, the guest. Now, here you have got x in terms of theta. Therefore, you must differentiate this with respect to this other variable theta. Therefore, you insert d by theta, d theta on both sides like this. Now, the left side becomes x, which becomes dx d theta. And the right side then will be 2 theta by e exponent theta. And I think Mr. Gone explained this in the last session to say, now we are differentiating the product of two functions, which are all in terms of theta. The first function you can say is 2 theta. That is the first function. And the second function is e exponent theta. Therefore, to differentiate this product, obviously we're going to use the product rule. And the product rule says differentiate the first factor, that is differentiate the first function. It will be 2 theta with respect to theta. Then obviously it's going to give us what? It's going to give us 2. Then you multiply it by the second function, that is the second factor fixed. So it will be multiplied by e theta. Then it will now be plus. Now you fix this one that was differentiated here. This is now fixed, which is 2 theta. Then you multiply it by the derivative of the second function. And our second function here is an exponential function. Now, to differentiate an exponential function, obviously you are going to use the exponential rule for the derivative, which says you must first fix it. That is exactly what we're doing. Differentiating an exponential function. You must first fix it, which is exactly what we did. And then you multiply it by the derivative of the exponent. So it will be multiplied by d phi of the exponent, because the exponent is theta, and which is 1. But that is not all. You then multiply it by the ln of the base. And in our exponential function, the base is e. Now, going back, what is the derivative of theta with respect to theta is 1. And what is ln E? Ln E is 1. Therefore, these two, they go off because they are both 1. Therefore, dx d theta is this guy. But now, before going further, make sure that this is in its simplest form. Or we can just simply what? Look, maybe there's a common factor here. Is there any common factor? Yes, there's a common factor. Then you can just simply take it out here. Or you can just simply leave it as it is. But note, put it at the back of your mind. That is to say, here, although I haven't taken out the common factor, but consider it that, no, this is a common factor. So that should you need it in the next step, then you can just simply quickly pull it. Or you, as we said, you can just simply take it. It will be this. That is a common factor. Then it will be 1 plus theta. Now, that is what we can derive from the first equation. Now you go to the second equation. The second equation, the same thing. Now, what you do is insert this again on both sides. On both sides of the second equation. Now, the left side, it will be y. And the right side is e exponent 2. Now, theta exponent 2 multiplied by e exponent 2 theta, which is how much now? Obviously, the left side now, it will not be dy d theta. Let us just write it properly. This is now dy d theta. And now, what about the right side? The same thing. You can see that the right side is in product form, is theta squared multiplied by e exponent 2 theta. So is the product of two functions, and each is in terms of theta. Therefore, we are going to apply what? The product rule for the derivatives. We differentiate one factor or one function multiplied by the other one fixed plus what? Now the other way around. What was differentiated, it will now be fixed, and what was fixed, it will now be differentiated. But remember this, the order here is not important. You can start by differentiating the first one, fixing the second one, or you can start by fixing the first one, multiplying it by the derivative of the second one. The order is not important, unlike the quotient rule. So here it will be the derivative of this, because this one is a power. It's not an exponential form, it's a power. Then we are going to use the power rule. The power rule says you bring the exponent in front. It will now be this 2 theta. And then from the very same exponent, you subtract 1. So it will be 2 minus 1, which is just 1. Therefore, we are just going to write 2 theta multiplied by the second function fixed. Plus now what? The other way around. What was differentiated here, it will now be fixed here. What was fixed here, it will now be differentiated. The answer will simply be what? It will be theta squared multiplied by, you differentiated this. This is an exponential function. Therefore, we have to use the exponential rule, where it says you must first fix it, multiplied by the derivative of the exponent, which will be the derivative of 2 theta, which is that theta, and then multiplied by the ln of the base. The base here is e, therefore it will be multiplied by ln e. Ln e is 1. Then from there, you can just simply what? Take out a common factor between these two terms. Obviously, a common factor will be what? There is 2 here, ne?
Yes.
There is 2 here. Or is it what you are going to say, Kone? Okay, perfect.
Yes, sir.
Okay, this is squared. Then from there, you can take out the common factor here. The common factor obviously will be 2 theta e exponent 2 theta. There's 2 here, there's 2 here, there's theta, and there's theta squared here. There's e exponent 2 theta here. Therefore, the common factor here is 2 theta e exponent 2 theta. In bracket will be how much? 1 plus 1 plus theta. And now don't forget, the velocity is dy dx. Don't forget, the velocity is dy dx. Now from there, you then combine these two. You then combine these two. This one, which is this one, with this one, combine this and this. This is this, this is this. Combine these two now to get what? To get now the velocity dy dx. How do we combine these two? Dx d theta and dy d theta. So now then this becomes, let me just squeeze it here. This then becomes, you're now going to say dy dx is how much now? Now you look at this. There is this variable that is joining the x and the y. X and theta, y and theta. Which variable now is joining these two equations? That is what? That is the theta. Because this is in terms of theta and this one is in terms of theta. Therefore, the y and the x are joined together by the third variable theta. Then you now introduce it here. That is, you're going to say dy dx. We know this is the same as dy dx multiplied by 1. But then how do you write it is 1? You then write it using the third variable. The third variable here is theta. Therefore, instead of 1, then we write d theta, d theta. Theta being the intermediate variable. Then from there, here, what you can do here is just simply what? To swap the denominators. Swap the denominators. Because this is dy dx multiplied by d theta d theta. What you do is you take this one. What is happening? You swap these two. This one comes here, and this one comes here. That is, now instead of x here, now we're going to write theta. Instead of theta here, you write x. Then from there, you substitute. Why? Because we've got a dy d theta. What is dy d theta? Dy d theta is this one. Then we replace dy d theta by this, which is 2 theta e exponent 2 theta in brackets 1 plus theta. And now this is multiplied by this one. Be careful here, because this is d theta dx. And what we have is what? Dx d theta. We have got dx d theta, but here we have got dx. This is dx d theta, but now this one is d theta dx. Therefore, how do you get d theta dx from what we have, which is dx d theta? It's just simply what? You just simply reciprocate this. Therefore, if dx d theta is this, that is this over 1. If dx d theta is this over 1, then what will be d theta?
Yeah, I think, Mr. Silwane, your video has stopped or frozen. Maybe it's the issue of network.
Mangema, please mute your mic. Apologies, students. Mr. Silwane is trying to fix the problem that is encountering with network now. So please bear with us. Give us like 5 minutes or so that we can sort out the issues. Thank you.
Yeah, Mr. Sulan, now you are back.
What is happening now?
Maybe it's the network.
On my side, everything is okay. It says the network, all right. The camera is on.
Yeah, everything is fine now.
Okay, no, my apologies, man.
No problem. You stopped. You stopped. We stopped hearing you when you were talking about d theta over dx. That it has to be 2e to the power theta was over 1. Then you're supposed to swap. You stopped there.
Okay.
Yes.
Okay. My apologies. Now, as I was saying, here what we have is dx d theta, which is this one. But here in our equation, we have got its reciprocal. It's not dx d theta here. We have got its reciprocal d theta dx. Then I was saying, if you want to say multiplied by, you want to keep on saying multiplied, then you must now multiply it by what? The reciprocal of this. Otherwise, you can just say now divide by, because multiply by the reciprocal of this. Multiply by 1 over this is the same as simply dividing by this, which we can just simply plug it in here. And then from there, this one will simply cancel this one. And the 2 will cancel a 2. And the e exponent theta will just simply cancel the 2 of the 2 of this 2 theta here. Therefore, dy dx, we are going to have it as theta e exponent theta. This is the velocity. Are we still together? This is the velocity. And then if you are asked about what? Anything related to the velocity, then you have to find the velocity equation. Maybe they can ask you about the time. When will the velocity be this? Or so on and so forth. Then you have to derive the velocity first, which is theta e exponent theta. Now, the next question, it will be, if we're still together, the next question, it will be, what is the acceleration? And we know the acceleration is the derivative of the velocity. Therefore, to find the acceleration, which is d squared, which will be this now, the acceleration, which will be d squared theta, no, d squared y over dx squared. That will be the acceleration. Let me just clean this properly. It will be d squared y over dx squared. That is the acceleration. Now, what is this? We know this is d by dx of dy dx. D and d, they will give you squared. Then from there you have got y, and dx by dx. Dx by dx is dx squared. That is the acceleration. Then from there, you just plug in your dy dx here, which we have it here. Dy dx, it is this one. So then we will now plug in dy dx here, which is theta e exponent theta. The same story. We are differentiating with respect to x. But this is not in terms of x. If it was this, then it was going to be straight the product rule, because we are differentiating something that is given in terms of theta and with respect to the very same theta. But that is not the case. Here we are differentiating with respect to x. Something that is given in terms of another variable. Then what do you do? The same thing. You say, oh, this is in terms of theta. Therefore, you must now introduce theta. Then how do you introduce theta? You say, by the way, this is the same as multiplied by 1. Then how do we write 1? We write 1 using our variable theta. This is 1. Then, like we've said, what do you do? Then you now swap the denominators. You swap these denominators now. You swap these two. You swap these two. This one comes here, and this one comes here. Simply, the x, the theta comes here, x comes here. Hopefully that makes sense. There, from there, what now? Then you now differentiate this. With respect, we are now differentiating this product with respect to theta, which will be straightforward because it will now be the product rule. Then you say multiplied by this, d theta dx. Not forgetting that we don't have d theta dx, but we have got its reciprocal, like we did it before. So then this becomes, let me just take this out, take this out, take this out. Then this is the product rule, as we have said, straightforward. It will now be 1. That is the derivative of theta is 1. We don't even have to write it. Then will be e exponent theta plus what now? You are now going to fix theta. You multiply it by the derivative of this because it's an exponential function. Then we will use the exponential rule for the derivative, which at the end, it will just be this one. Then you say multiplied by, or you say divide by, it doesn't matter. Let us just say divide by, because we don't have d theta dx. We have got what? Dx d theta, which was this one. Don't forget dx, which was this one. So therefore, here we are still going to say divide by this theta in brackets this one. And here, yes, you can see, you can just take the e exponent theta out, because take the e exponent theta out in the numerator, then it will be e exponent theta in brackets, it will be 1 plus theta over what? Over 2 e exponent theta in brackets 1 plus theta. And now from there, this one cancel this one. And the e exponent theta cancel the e exponent theta. Therefore, the acceleration, it will now be simply 1 over 2. And we are done. And don't forget this. Don't forget this. This is given what? These two, yes? Can't see your name, but I saw your hand was up. You can just simply unmute yourself and ask.
No, I was just reacting with a thumbs up, saying thanks. It makes sense like that.
Oh,
I was reacting like that. Yep.
Okay, no.
Thank you.
I didn't. Thank you. Any question before we move on to, as long as you have got what? These two equations, we call them parametric equations. Then as you can see, the velocity, obviously they will say in the exam, they will say find the velocity and in brackets give you the notation for that velocity. And it will be dy dx. And as we have said, dy dx is where you have got what? An equation in terms of y and x. And all what we do is what? You just write d by dx on both sides of that equation. Then from there, it will simply be straight differential rules. But unfortunately, there is no equation here, which is in terms of y and x. Then we have said, what do you do? Then you just derive whatever you have, you can, from each of these two equations. This is x in terms of theta. Then you derive dx d theta. This one is y in terms of theta. Then you derive dy d theta using the applicable rules. Then from there, you then write dy dx using what you have derived from this and this. But obviously, you introduce what? That middle variable, which we have said is theta in our case. Then we're going to say dy dx is equal to dy dx. Then you say multiply by 1. But then how do you write that 1? Then you say d theta divided by d theta, because theta here is our middle variable. Then from there, you swap the denominators. Instead of dy dx, it will now be dy d theta. Here, it will now be d theta dx. But don't forget with the second factor now. This one we have it. You can just simply copy it and paste it here. But what about the second factor? You copy its reciprocal. Then from there, everything should just unfold nicely. The same thing with the acceleration. The acceleration is d squared y divided by dx squared. But d squared y divided by dx is what? Is the derivative of dy dx with respect to x. Then you substitute what is inside the brackets. Substitute what is inside the brackets. Because here we had, don't forget, this is dx, this is dy dx. That is this notation. Because many students, they get it wrong there. You say d squared y dx squared. This is the derivative. This squared here is this d by this d. The squared here is this d by this d. Then it will give you the squared. Then we've got y. And the dx by the dx, it will give you dx by dx. Then you substitute dy dx, which will have it from the velocity. Then here, you just replace dy dx. Then from there, this, it will be dx, no, d by dx. And this one inside the brackets is not in terms of x. Then, because it's in terms of theta, whatever, I can't remember the exact number, then you now introduce the variable theta. Then it will not be d by d theta. We are now differentiating this with respect to this. That is d theta by e exponent theta. You are now differentiating with respect to theta, which is just straight the product rule. Don't forget again here, because this one is swapped. This is theta here. This is this. This is straight the product rule, differential. Don't forget this. It will now be the reciprocal of what you have derived from x equal to. That from there, everything should just unfold nicely. Any question before we move on to the next question? Is there any question before we move on to the next one? Parametric equations, they're straightforward. Sometimes they can just say what? Differentiate what? Find the velocity, this, where theta is this. Then obviously you are going to get your dy dx. Then you are going to replace theta by the given theta. The same story. They can just say what? Find the acceleration, which is d squared y dx squared, where theta is equal to this. Therefore, you find the acceleration equation, then you replace theta there. I think it's straightforward. The question is simply what? The differential rules, because this can be any function, meaning to differentiate it, it will now be any now differential rule. You just have to make sure that you know your differential rules. Now, if there is no question, then we can move on to the next one. Is there any question before I erase everything? Now,
there's no
the next
hand.
one, no hand. Now, the next one, it will be what I've said earlier on, that is multi-variable functions. Unlike this one, parametric equations, sometimes it will be possible to do what? To substitute here. Make theta here the subject of the formula. Make theta the subject of the formula. Then come and replace it here. Then we are going to get an equation in terms of y and x. But here it's not possible. Here it's not possible. But in some instances, you'll find that maybe something like this. Maybe you have got x equal to 2 theta and y equal to this. You can see that here, you can just make theta here a subject of the formula and write theta in terms of x. Then come and what? Replace your theta here. Then you are going to get a function y in terms of x only. This one is possible. But with this one, it then becomes impossible. Therefore, the only way to get dy dx and acceleration, it is just to differentiate each and what. Now, another one is what is called what? Multivariable functions, where you cannot now rewrite that using only 2 variables. Because they'll say z equal to what? Say x squared plus whatever, 3xy, something like this. How many variables? One equation, unlike parametric equations, where is 2 equations and more than 2 variables. But now here is only one function. And how many variables? x1, that is z. Another variable is x, and another variable is y. Another question is, we call it multivariable functions. Now the question is, how do we differentiate this now? How do we find the derivative? Not forgetting that dy dx is where you have got what? 2 variables, y and x. But now here do we have 2 variables? No. How many? There are 3. They can as well be what? 4. They can be what? 5. It can be any number of variables. Now the question is, now how do we differentiate using this notation? Because this notation, you have got 2 variables, y and x, and here you have got more than 2. Then how do you differentiate this now? What we are going to do here is what? We are just going to modify this. The very same notation for the derivative, we modify it so that it can help us in here. But don't forget, the derivative of this, say 3x squared. Don't forget this. What is the derivative of 3x squared? We are saying 3 here has got nothing to do with x. 3 is independent of x. It's a constant. So then how do you differentiate a constant multiplied by a function? How do you differentiate a constant multiplied by a function? We have said you can just take the constant out, then take the constant out because it has got nothing to do with this x. You take it out, then it will be 3 multiplied by this. Here you cannot take the x out because we are differentiating with respect to x. You can only take the constant out. Then this becomes this 3, which is out, multiplied by, now you differentiate this using obviously the power rule for differentiation. And what is the derivative of 2x? Therefore, the answer is how much? 6x. Now, when it comes to this multivariable functions, we are still going to use this property. If something is a constant, then you take it out. Then you differentiate whatever is inside. Okay, now, if that is clear, then we are now going to learn how to differentiate multivariable functions like this. But now, to distinguish it is, that is to distinguish what? The derivative of 2 variable functions and the derivative of multivariable functions, as we have said, we're just simply going to modify this. Instead of using an ordinary d, we are going to use these kinds of D. That is cursive D. And once you see this cursive D, then it means here we were differentiating multivariable functions. Then we're saying is Y, then you write this. Instead of ordinary D, we write cursive D. Ordinary D, we write cursive D. Now, with this notation, it simply means what? The only two variables here, when we say cursive D, Y, cursive dx, the only two variables, it will be Y and X. Only Y and X. Anything else, it will be treated like a constant. Hopefully this makes sense. Anything else, it will be treated like a constant. And because it's treated like a constant, therefore, we're going to take it out like we did with 3 here when we're differentiating 3x squared. Does it make sense before we move on? Yes, it makes sense. Now, the given example here is the following. They say, find this. Find this. Let me just clear this one because we don't need it anymore. Just to give us space, they say, find this. Cursive Z over what? That is not cursive Z, D squared over, that is dx squared. And second derivative like this over dy squared. And what is this? This is simply what? The partial derivative, we call them partial derivative. Partial derivative with respect to x of this. This is this. This means this. The cursive D and the cursive D, they will give you what? Cursive D squared. Then from there, you have got Z. And this, with respect to x here, cursive dx, it will give you this. The same thing with this one. It will not be what? This is by, it will be this. The same story. We can say d squared. We can say something like this. Now, this means the partial derivative with respect to x of this. Of this. Meaning, with respect to y, it will be the inner one. That will be the first one. Meaning, you must first get this one. That is the partial derivative of z with respect to y. Where the only two variables here, let us emphasize this. The only two variables here is z and y. Hopefully it makes sense. We can still ask you to find this, or they can still ask you to find this one. To find this one. This one is the outer one. dy is the outer one, meaning it's the last one. This one is the inner one, meaning it must be the first one. This is the cursive, that is the partial derivative of this. Meaning you must first find this one inside the brackets. But don't forget, for this one inside the brackets, the only two variables is z and x. Hopefully it makes sense. Now, find these two, given it is. But remember, all the partial derivative rules, they still hold. They say your function is z equal to, let me just check it here, z equal to x e exponent xy. Find this one and find this one. Let us just keep up the pace. What is this? We know this one, as we have said, it is this. Let me just write it here. It is this one. Is this. Meaning we must first find this inside the brackets. Meaning we must now insert this on both sides. The denominator dx. On both sides. Write it on both sides. Write it on both sides. Write it on both sides. And now come back. What is the left side? The left side is z. And what is the right side? The right side is this one. Good. And what is the left side now? The left side is now this. And what is the right side? Don't forget, it is we're differentiating with respect to x. But don't forget, it is only z and x which are variables. It's only z and x which are variables. Therefore what? Therefore this y here, it will be treated like a constant. This y here, don't forget, this y here, it will be treated like a constant. Then how to differentiate this product? It will simply be what? The product rule. Because this is in terms of x, which is our variable x, and this is e exponent xy. See this as x multiplied by 3, because y is a constant. Then just see this e exponent xy, because y is a constant. Then see this as what? E exponent maybe 2x, or maybe 3x, or maybe 4x, because y is a constant. So then how to differentiate this? It will just be what? The product rule, where you now differentiate x the usual way, which is 1. Then you multiply it by this one fixed. Then you say plus. Plus what? Now the x is fixed. Now be careful here, the x is fixed. Now you differentiate it by this one, where you see y as a constant. Because this is an exponential function, we know we must first fix it. Multiply by what? The derivative of like 3x or like 4x, because y is a constant. And what is the derivative of this? With respect to x, don't forget, with respect to x, the answer is going to be what? The answer is going to be y. It's like differentiating 3x. Then, which we can rewrite it as what? Just xy this, which we can rewrite it as xy this. That's all. Any question thus far? Now, if nothing, then what about this now? What about this? What about this one? As we've said, this means the partial with respect to x of dz dx. It will be this. And what is the partial derivative of z with respect to x? We have it here. We just have to plug it in here. The partial derivative here, that is this one. We just have to plug it in here. Then it becomes what here? It becomes e exponent xy plus xy e exponent xy. Then you differentiate it. But don't forget, it is only z and x which are variables. Then you differentiate this. Then what will be the answer? Y e exponent xy. Then plus what now? We are differentiating with respect to x. And there is xy. Don't forget, y is a constant. This is like differentiating 3x e exponent xy. It's like differentiating 2x because y is a constant. And obviously, to differentiate this, we are going to need what? We are going to use the product rule. And this, the derivative of this is going to give you a binomial. Then it's better what? To write it inside the brackets. But because this is plus, there's no need to write it inside the brackets. I'm just saying generally. But if it is plus, there is no need to even put brackets. But if this is minus, then be careful, because all the signs inside here, they are going to change. So it will depend. So now here, because it's plus, therefore there is no need to even use brackets. Now you differentiate this. It will now be the derivative of this with this one fixed plus 1. Now you are fixing xy. You are fixing xy. You are multiplying by the derivative of this exponential function, not forgetting that y is a constant. Therefore, the answer will be how much? Y e exponent xy. Now from there, you can, because what? The y e exponent this and y e exponent this, you can't leave these two terms like this. The answer will be obviously be 2y e exponent xy. And then this one it will be xy squared. Xy squared e exponent xy. That will be this one. And surely, if you can derive this one, surely you can also derive this one. You can also derive this one. It's no problem. You can also derive this one. Because here it's only z and y, which are variables. It's only z and y, which are variables. Then you have to treat x here like a constant. You have to see x maybe as 4 or any constant 7. It can be any constant. Hopefully that makes sense. Any question? Any question? We have a question before we move on to the next one. Yes, yes. Lucas?
Yeah, sorry, I think the image just got stuck there, so I can't see. I'm not sure if anybody else is having the same difficulty, but for the content, you know, what you were discussing with the product rule at the end, that makes sense. I don't have any questions to that.
The problem is what? My camera or what? Maybe is faded, the pictures.
No, it's just not broadcasting any image. So it's a bit stuck. I'm not sure if it's on my side. But other than that, yeah, I can understand what you meant. Yeah, with the product rule at the end. Just can't see. But it's easy enough. I don't think I need to, see the answer.
What about the others? Can you see what is written here? Mr. Gone, can you see
Yes,
it?
yes. Yeah, I can see.
Maybe
Yes.
Lucas, the problem is on your side.
And then
I think
the
also myself.
Deborah is on is her hand is up.
Yes, Mr. Sulwani, I also have the
Yes,
same.
yes.
I have the same problem with Lucas. Unfortunately, the part where you were explaining when it got frozen, I think that is a very important part that we need to really understand. So I don't know how you can do it to at least, go back and explain that part so that we also follow what you are writing.
Yeah, that would be from product rule at the
This
end.
one?
The last product rule for
Oh, the
XY.
last part.
Yeah, just the last product rule for differentiation.
Okay. Okay,
Just the
okay,
last
okay.
one, yeah.
Let us revert to that. We have said it is d squared y, that is the partial derivative of this. Don't forget notationally. This means what? This means the partial that is with respect to x of partial of z with respect to x. Can you see this part? If yes, then
Yes,
we're just
yes,
simply going to plug in. Yeah, we're just simply going to plug in what is the partial of z, partial derivative of z with respect to x. And we have said is what? What is the partial of this? We have said is this one. So let us just plug it in here. Let us just plug it in here. It is e exponent xy plus xy e exponent xy. That is this one. Then from there, if we are together, then let us just simply go through this again. Now, this becomes what? This becomes what? Now, we are saying what? Don't forget, the only variables here is z and x. So anything else, it will be treated like a constant. As I've said, don't forget the derivative of this. What is the derivative of this? 4 is a constant. Then you can take it out. It's a constant. You can take it out. Then it will be 4 by the derivative of this, because it will be the derivative of x squared with respect to x. In terms of x, with respect to x. Then it will be the power rule. Then it will be 2x. What we did here, we took the 4 out. It will just simply be this constant 4, this constant 4, multiplied by the derivative of this. This constant 4 multiplied by the derivative of this. So the same story here, the same story here. The only two variables here is z and x. Therefore, this y is a constant, it's fixed. So then what will be the derivative? See this as like what? 2x. Because y is a constant. See this as like e exponent 2x. What is the derivative of e exponent 2x? It will be what? It will be this 2. Because you are now going to fix it first. Let I just write everything. You are going to fix it first. And multiply it by the derivative of this. And what is the derivative of this? It is 2. It is 2. Therefore, if this 2 is y, if this 2 is y, then what will be the answer? This 2 is y, then what will be the answer? It will be this. And obviously, if you write it, you are going to write it before. It will be this. Now, it will not be plus. Plus now what? The derivative of this. Don't forget, y is a constant. Here, it's like differentiating by 2. It's like differentiating 2x. The y here is 2. Hopefully it makes sense. This is x, y. But don't forget, y is a constant here. Y is a constant. But now, because x here, we're differentiating with respect to x, therefore you can't say x is also a constant. Y is fixed, meaning y is a constant. Then what is the derivative of this product? It's like differentiating 2x e exponent 2x. It's like differentiating this. Then it will be the derivative of this, which is 2, which is that constant, the derivative of this, the derivative of this. It will be 2, that is that constant. Here, our constant is y. Does it make sense? Then you multiply it by e exponent xy. You see. Then you say plus. Plus what now? The xy is now fixed. Then you multiply it by the derivative of this. That is, you multiply it by the derivative of this. What is the derivative of this? The derivative of this exponential function will be how much? You must first fix it, multiply it by the derivative of this, which is 2. Then multiply it by the ln of the base, which is ln e, which is 1. We don't even write multiply by ln e, because ln e is 1. Therefore, this becomes what? You are now going to fix this, e exponent xy. Then you multiply it by what? You multiply it by the constant here. Our constant here is 1. Then we're going to multiply it by y. I'm not sure whether is visible here. Is it that part that you missed, Deborah? Then from there you remove brackets, if that is the part that you missed.
Yes, that is the part that I missed, yes.
Does it make sense now?
Yes, it does.
Yeah, then because this is plus, then when you remove brackets, it doesn't, the signs inside the brackets won't change. Then obviously you can't leave your answer in this form, because this one and this one are like terms. Y e exponent xy. Don't forget it. This is y e exponent this and e exponent y multiplied by e exponent this and y multiplied by e exponent this. That will be 2. Then this should be what? 2y e exponent say xy, and that one is what? Xy squared e exponent xy. And that will be this. And we said, if you can get this, if you understand how we arrived at, surely you will be able to get what? D squared. That is the partial derivative of this. We call them higher derivatives. Any question thus far? Any question thus far? We don't even have to do this. Because definitely if you can do this, you can as well do this one. Because here, our only variables is now what? Z and Y. So you're going to treat X as a constant. Like we were treating Y here as a constant, here we are going to treat now the X as a constant. Now, if there is no question, then we can move on to the next question. Or do we need a break? Looks like we still have a long way to go. Looks like we still have a long way to go. We need a break. My guess is no, although it's what? It's past 5 now. Let us just move on and see how far we can go. Otherwise, we won't finish everything here in these 2 hours. Now, the next question. Remember, we're looking at those exam type questions. We're not looking at everything, but exam type question. Looking forward to that exam. Another exam type of question, it will be like this. Now, is one of the applications of partial derivatives, meaning you must know partial derivative first. And after, now we're going to look at one instance where one can apply it. So it will be like this, which is called what? Just small increments. Is there in your formula? In your formula is given as small increments. It will now depend on what are those increments, small changes. Now, the example that I was asked to do here is as follows. You say the equation is theta is equal to. It's still an example of multivariable functions. Now you are given theta as K H L over the square root of V. That is this. How many variables are here? Is theta 1, K 2, H 3, L 4, V 5. Looks like we have got what? 5 variables. But that is not the case. They are saying what? Where K and L are constants. Let me just write it. K and L are constants. Please, these two are constants. Therefore, how many variables? Theta is a variable. Therefore, H is also a variable, and V is a variable. Therefore, we don't have 5 variables. We have got 3 variables, theta, H, and V. Now, if you read further, they say now the following. They say there is a possible error when measuring these variables. We don't know what is Q, what is H, what is V. All what you know is they are variables. So they say when measuring H and V, they tried to accommodate those errors because this is measurement. So sometimes you can over measure, you can under measure. They say there are possible errors of what? Plus or minus 0.2% when measuring H and V. When measuring this H and V, they say accommodate 0.2% of error, meaning you can over measure, you can under measure. Now, How do you see this? Don't see this as just two numbers, +2 and -2. This plus or -2, in fact, is an interval, meaning there is -2 here and there is +2 here. They say in the measurement, if they got the measurement perfect, exactly, then there won't be any error. Therefore, the error will be 0. If you over measured, then maybe it will be what? Maybe here, because here is 0, minus this is plus 0, this. Maybe when you over measure, it will be 0,1 somewhere here, or 0,01, or 0,02, or 0, something, until 0,2, meaning this is the maximum. The same story with this side. So the measurement here accommodate any error in between this, any error in between this. Hopefully it makes sense. Now, this is what is happening now. They say with these possible errors of 0, of plus or minus 0,2%, how will these errors now in measuring this will affect this Q, because Q is dependent on H and V. So then how do you calculate the effect of this on this theta? Now, as I've said, the formula is there in the information booklet. It is given as that is the delta theta. That is the small increment theta. We call it delta. Delta theta. It will now be what? The question here is find what? Find the small change in theta. Find a small change in theta. How will this, that is this, the measurement in H and V, affect the theta, because the theta is dependent on these two. Now, the change in theta, that is delta theta, it will be given by what? It will be given by the partial derivative of theta with respect to one variable. Let's say with respect to H. Then multiplied by the error in H. With respect to H by the error in H. Plus what? The partial derivative of theta with respect to the next variable. And what is our next variable here? Is V. Then it will be multiplied by the error in V. It will depend, because now K and L are constants. Then we don't have to, because there's no change in constant. A constant is just a constant. It doesn't change. And once you understand this, then you can run with it. Mudau equal to how much? Then you find now, you must now find this, the partial derivative of theta with respect to H. From here,
Mr. Silwane, you are muted. Mr. Silwane?
am I audible now?
Okay, yeah, yes.
I don't know what happened here.
Okay.
Maybe I put this, what? I don't know. I'm sorry, man. Then what then? The partial derivative of theta with respect to H, as we have said, you just insert this guy on both sides. You just insert this guy, partial with respect to H on both sides. Then the left side will be this. Then you now insert it on the right side. What will be the answer if you set it on the right side? K is a constant, then we're going to take it out. L is a constant, you're going to take it out. V is a constant according to this. According to this, the only two variables is theta and H. Therefore, K is a constant, we're going to take it out. L is a constant, we're going to take it out. V is a constant for this notation, we're going to take it out. Therefore, what will be the answer? It's going to be KL over the square root of V. This is going to be this. Hopefully, we are together. Then multiplied by what now? That is the change in H, meaning here the error in H, because here is not a change in H. You have to interpret it as the error in H. What is the error in the measurement of H? They say we must accommodate plus or minus 2%. Therefore, instead of this, the error in H, now we're going to say plus or minus 0.2%. But be careful. This is plus or minus 2% in measuring H. Then we now say in measuring H. This is this. This is this. You are now going to replace the error in H, or that's a small increment in H, or the change in H by this, which is plus or minus 0.2%, but now you have to say of H when measuring H. If this is okay, then we are now going to look at now the next one. That is this part then, this part, which is plus. Let us just squeeze it here. Now, what are the two variables for this one? Partial derivative of d, of theta, with respect to v. This theta and v are the only two variables, meaning we are now going to write now this on both sides. You are going to write the partial, that is cursive d, over this on the left side, and you write it on the right side as well. The only variables is theta and v. Therefore, k is a constant. Then we're going to take it out. H is a constant. We're going to take it out. L is a constant. You're going to take it out. Then we are only going to differentiate the square root of v. We're only going to differentiate v exponent minus half, because we'd have to take it up then to avoid using the quotient rule unnecessary. Then take the square root of v up, it becomes v exponent minus half. Then you differentiate v exponent minus half appropriately. It will not be what? It will not be minus half. You just write it here. Minus half by what? V exponent. It will not be minus half minus 1, which is now become minus 3 over 2. Then you say multiply by this now. What is the error in measuring V? They say it's also this. Like what we did here, it will not be multiply by what? Plus or minus 2, no, there is 0.2, 0.2% in measuring V. Don't forget this, in measuring V. Then from there, if we're still together, it will be equal to, from here then, you can see that this now, this H, because of means multiply by. This H, when you multiply it by K here, L here, and this, it becomes H, K, L over the square root of V. Then it will be multiplied by plus or minus 0.2% now. Now, be careful here, be careful here, be careful here. Let us go back here. Let us go back and try to understand this. I can take this one out. Let us go back and try to understand this one. Say this. What is 3 multiplied by plus or minus 2? What is 3 multiplied by plus or minus 2? This gives you plus or minus 6. And what is minus 3 multiplied by plus or minus 2? minus 3 multiplied by plus or minus 2. It gives you what? Plus or minus what? Plus or minus 6. Because it will be negative 2 multiplied by positive, no, negative 3 multiplied by this, it's going to give you negative 6. And negative 3 multiplied by negative 2 is going to give you plus. So it doesn't matter what the sign here before the 3 is, as long as you are multiplying it by plus or minus. So this sign before this one, it doesn't matter. So what we are going to do here, we are now going to take this minus half. We are not going to take the minus half outside.
Mr. Silwane,
Yes, yes, Mr. Gone.
they're asking if you can, maybe if you've got a light that you can switch so that, because it's becoming darker.
It becomes that. Let me
Yeah.
switch it on. Is it okay now?
Perfect.
Perfect. Okay. Now, as we were saying, here, do not take the minus here out and put it here. And this one becomes minus. Why? It's because here we're looking for the maximum error or the maximum change. So here then we must avoid what? Mixing signs. Because once you mix signs, the signs, you mix the plus and the minus, then it's not going to give you the extreme. It's going to give you something in the middle because the two are going to compensate each other or cancel each other. But now because minus half multiplied by plus or minus and plus half multiplied by plus or minus is the same. Then here you take the minus half, you multiply it by this one first. Then it will become plus or minus 0.1. Minus half multiplied by this. It will not become what? Plus or minus 0.1. And this V, and this V here, this V exponent 1, and this V exponent minus 3 over 2 is going to give you V exponent minus half. Because it will be minus 1.5 plus 1. It's going to give you minus half. And because it's minus half, then we're going to take it down. It will be the square root of. Therefore, this one will not be plus 1. K, because it will be this K, H, L divided by what? The square root of V. It will be this. Multiply by plus or minus 0.1 percentage. And as you can see, this is now a common factor. You can just take this out. It's a common factor. You can take it out. Therefore, it will be this. Let us take it out. It will not be out here. And this is plus here. And now from there, you can see that HKL over this. What is this? This is our Q. It's our theta. I'm sorry, because our theta was given as KHL over the square root of V. This is our theta. Therefore, we can replace it by theta. Then it will be this. And when you add these two, they are going to give you 0, that is plus or minus 0.1 percentage. This plus or minus 0.2 percentage. Okay, just need to take the plus or minus out. Okay, just need to take the plus or minus out together with the percentage. Take the plus or minus out together with the percentage. It's going to give you what inside you are going to be left with 0.2 plus 0.1. Inside we're going to be left with 0.2 plus 0.1. And this now definitely is what? Is plus or minus 0.3 percentage multiplied by theta. And this is of theta. And then from there we are done. Therefore, in measuring the H and the V, if there are possible errors of this plus or minus 0.2%, these possible errors, they will give you this. Therefore, you have to accommodate these possible errors when we are looking at the theta. The theta, which is dependent on this H and V. H and V coming with these possible errors. Therefore, expect what? plus or minus 0.3 percentage in the measurement of theta. Yes, Deborah? Deborah, unmute yourself and ask a question. I see your hand is up.
Yes, Mr. Sulwane. I was
Yes,
asking
yes.
about the plus and minus signs. In my steps, should I omit those signs? It means I'll be penalized.
Yeah, you will be penalized. Why?
Even if at the end my answer I write it as plus minus this much, but now within the steps I must always, indicate that plus minus wherever I write those errors. Is that what you are advising?
Definitely, because what? Each step here, the steps they precede. This step comes from this one. This step comes from this one. And definitely you cannot leave what? Let's say you are working with centimeters. You cannot leave centimeters here in your calculation and certainly then the centimeters from nowhere comes in. I'm not sure about that one. Maybe Dr. Dlamini can come in here, whether she will allow it or not.
I get it, sir. Because sometimes, these are some of the silly things that we omit in our exams and we get penalized. So thank you, sir.
Yes, but as I'm saying, maybe Dr. Dlamini is the perfect person who can answer that and tell you whether she will be lenient with you or not. But some markers or some lecturers, they are very strict. They will say no.
Thank you, sir.
All right. Any question before we move on to something else? Is there any question? If nothing, then let us look at what is called root mean square. Root mean square. In your information booklet, I think it's there. It's even written as what? Abbreviation RMS. Root mean square. By root mean square, they mean the following. They mean the following. Let me just hear this. They mean the following. Now, take for instance, you have written 3 assignments. Say assignment number 1. Say assignment number 1, you got 80%. And assignment number 2, you got 90%. And assignment number 3, you got whatever, say 70%. So what will be your average? That is, what will be your mean? The average. Now, these are disjointed. They are separated. So to find the average of this, you just simply what? Add the marks and divide them by their number. How many assignments? 3. Then what about their marks? It will be 80 plus 90, 170 plus this, 240. Then it will be 240 divided by 3. Then it will be somewhere 80. Therefore, your average will be 80. But in this one, well, they are going to ask you to say y is equal to x squared. And we know, unlike the ones here, unlike your number of assignments, unlike your assignments, they are what? Here, they are just joined. You cannot separate them. But now they will say what? Find the average of the y's. Find the average of the values of y between where x is this up to where x is this one. Now the problem then becomes what? Because your x are joined, and therefore so is your y. So then how can you find the average of something that you don't even know their numbers? Because here we know their numbers, then we divide by their numbers. But here, because the x are joined, therefore their respective y's, they are also joined. Therefore, you cannot know their numbers. Then how can you find their average? But fortunately, with integration, we can calculate that. With integration, we can calculate that. then that is under the root mean square. And the formula is there. Root mean square. What is root mean square? It will be RMS is equal to the square root of this. 1 over B minus A. What is B minus A? We are going to say from where? From where X is equal to maybe 3 up to X is equal to 7. So the B here is the upper limit and the A is the lower limit. Then from there you say integral. The integral of what? You take your function now, you square it. It will be the function squared. Then you integrate this with respect to X. That is the formula. And once you get the formula right, then you should be able to run with it. So here, the question here was our function, it was given as I equal to cos of 2 theta. Then they say from where to where? From, that is t equal to 0 up to t equal to pi over 2. Then how do you answer this? Now, if you look at this, now what is B? B, it will be pi over 2 here. B, it will be pi over 2. And what is A? A, it will be 0. And what is our function? Which must be squared now? Which must be squared? Our function, it will be cos 2t. Therefore, the function squared, it will be cos squared 2t. And this is in terms of t. Therefore, our function here, we can just plug them in here. B, we have said, is pi over 2. Then it will be minus 0. And obviously, this is how much? It will be the reciprocal now, because the denominator here, it is just this. And therefore, this is just simply what? The reciprocal, which is 2 over pi. And now from there, what is our function here? It will not be the integral of our function is cos 2t. Then you square it, then it becomes cos squared 2t. Then this is not in terms of x, it's with respect to t. Then from there, you integrate this. But as you can see, then in each and every step, we're not going to write the square root, the square root, the square root, the square root, the square root. Every step will have the square root. And this is not going to look nice. So then what do? You just get rid of the square root right from the first step. Then how do you get rid of the square root from the first step? You square both sides. Then you avoid having to rewrite the square root. The square root, how many times are you going to rewrite the square root? Then here, you just have to square both sides. Then the left side becomes this. But don't forget, your final answer here is not the correct answer. Is still the square. Then from there, when you get the answer here, then how do you find the final answer? You find its square root. Don't forget. So here, we are now going to integrate this. I think we have forgotten what? We have forgotten to include the interval here. From what? From 0 up to pi over 2. Then okay, now look what I've done now. Then we can just take this out, right? Now look what I've done now. That's right. Return integral sign to integral sign. Then from there, you integrate this. Like before, 2 over pi is a constant. Then you take it out. It will be 2 over pi. You take it out. Then it will be from 0 to pi over 2. Then you integrate this. That will be the challenge now. What is the integral of cos squared 2t? Anybody who can tell us that? Or what will be the approach here? Cos squared 2t? We know cos squared and sine squared. These are not standard integrals. It's unlike integrating x squared. What is the integral of x squared? This is straightforward. It will be the power rule. It will be x exponent 3 over 3. But now, what about this one? we can't use the general power rule. We can't use the general power rule. Why? Because with the general power rule, you need F and its derivative. That is, with the general power rule, the general power rule is like this. Don't forget, the general power rule is like this. You need N. And you cannot say, okay, I've got N here because I can rewrite this as this. You can't say that. You can't say that. Because yes, your N is going to be 2. Your N here is going to be 2. Your N is going to be 2. And what is your inner function? What is your function? Yes, somebody can say, no, my function here is cos 2t. But then you need the derivative of cos 2t here, which is not there. Therefore, here is not straight the general power rule. Here, what you do here is what? You write cos 2t using what? No, you write cos squared t, cos squared 2t. You write this. Using what? Using cos 2t. Using from, this is derived from the compound angle formula. Don't forget that, the compound angle formula. To say what is cos 2x? Cos 2x, it will be cos squared x minus sine squared x. Don't forget, cos 2x is this. Now, depending on whether you are integrating cos squared or you are integrating sine squared, then you change either cos squared into sine squared, or you change sine squared into cos squared. Just be careful. Now, here we are integrating cos squared. Therefore, here you're going to change sine squared. You're going to write sine squared, although this you have to know. You don't have to rewrite it during the exam. You just have to know it. Then this becomes what? Because this is plus now. It becomes, no, this is cos squared. I've changed sine squared. Then this becomes this. Then it becomes 2 cos squared x minus 1. Then you take the minus 1 this side. Then from there, you are going to remove the 2. Therefore, cos squared x is how much? Half in brackets 1 plus cos 2x. It will be this. But now here we are looking for cos squared 2x. We are looking for cos squared 2x. After replace it here. What is cos squared 2x? You can see that, oh, this x here is just half of this one. Or this 2x here, this 2 here is twice this. The 2 here is twice this, x. Because it's 2x, this is x, this is 2x, this is x. What about if it is 2x here? If it is 2x here, then it becomes half in brackets 1 plus cos what? It will be twice this, which is 4x. So instead of cos squared 2t, we are now going to write half in brackets cos 4t instead of this. Hopefully, this makes sense. Therefore, this now, if we're still together, take the 2 over pi out because it's a constant. Integral of what? From 0 up to pi over 2. Instead of this, we are now going to write this. Hopefully, we are still together. We are going to write this. We are going to write this. And you take the half as well outside because it's a constant. It doesn't depend on t. If you take the half out, this 2 of half and this 2 of pi, they're going to cancel each other. Therefore, these 2 are out. These 2 are out. Then you are now integrating this now. Then this will be 1 over pi, 1 over pi. Integrate this with respect to t. Then will be in brackets what? What is the integral of 1 with respect to t? It is t. And what is the integral of this one? With respect to t. I think Mr. Gonet took care of that in the last session. You just simply have to go straight to the answer. What is the answer here? It will be how much? Remember, there must be the derivative of 4t here.
Sine 4t.
And the 4t is not there. It will now be what? 1 over 4 sine what? 4t. Then we are now going to evaluate this. From where to where? From 0 to pi over 2. Where you have to open 2 brackets now. In the first brackets, you write this. with t replaced by 0, minus in the second bracket, you write the same thing, but now with t replaced by what? Pi over 2. So the answer then will be 1 over pi. We don't even have to talk about the first brackets, because in the first bracket, everything will be 0. Then from there, hopefully everybody will finish this. I'm just looking at the time here. Otherwise, we won't be able to do as much as we wish to. Any question? If nothing, then let us look at another application of the derivative. But remember this, if you are still not sure, or if something here, you are still not okay, then you can just simply what? Email me, then I will be able to help you go through it. Because it looks like there is much here to cover. Therefore, definitely we won't be able to do everything as the way we wanted it to be. I'm just looking at the time here. It looks like it's just going to cut us off before we finish. Now, the next one is about the area of the region bounded by two graphs. The region running from a certain value up to a certain value. Say, in our example here, we are given this one. They say, find the area of the region enclosed by the following graphs. Find the area of the region bounded by the following graphs. The first graph is y equal to, let me just check here, y equal to, where is it? Y equal to x squared. And the second graph is y equal to minus x squared plus 4x. Let me repeat this. They say find the area of the region enclosed between these two parabolas. Hopefully, they will give you the sketch in the exam. But even if they don't, now you know how to sketch these two graphs. So how to sketch these two graphs? The first one is y equal to this. Let us just call this y1, and let us call this y2. This is y1, the parabola. And what about this one? This one obviously will be what? If you sketch it, one x-intercept, it will be 0. The other one, it will be 4. Therefore, it will be something like this, where x here is 4, and therefore we're talking about the area of this region. So what is the area of this shaded region? The formula for the area of the region enclosed by graphs, it will not be what? You are going to say the integral of. The integral of what? You take the top boundary, the function that forms the top boundary. Now, if you stand anywhere inside this region, and maybe you raise your hand or whatever, which graph will you touch? Definitely, you will touch this, which is part of this, It must be inside this. If you stand here or whatever, then this part, this graph, or part of this graph will form the top boundary of this. Then it will not be what? It will be minus x squared plus 4x. Then you subtract what? You subtract the graph or the boundary or the lower boundary. If you are here and then you want to maybe go down, obviously you will be prevented by part of this graph. It will depend. When you are here, go down, you touch this. When you are here, go down, you touch it. Therefore, this graph or part of this graph is the one that will form our bottom boundary. And this is y equal to x squared. Then you are going to subtract this. It will be the top function minus the bottom function. Then, as you can see, this is in terms of x. Therefore, we are going to integrate with respect to x. Then we are now going to say this region is enclosed between which two vertical lines? That is, this region, where does it start? What is x there? It starts here, where x is 0. Now, it runs, it continue until it's somewhere here. And what is x here? It will be the x here, which is the point of intersection between the two. How to find the point of intersection of these two? The y here is y of this is the same as y of this one. Therefore, it will just be simultaneous equation. Then obviously, what is y? You replace y here by x squared. Then it will now be what? You can just bring this one to this side. It will now be 2x squared minus 4x equal to 0. Then you solve for x. 1x, it will be 0. Another x, it will be 2. Then here, it will be 2. Now from there, you integrate this. Then you get your answer. Any question thus far? You get your answer. Okay, let me just bring something. Let me quickly bring something. If fine, any question, any question, any question? Okay, if fine, let us just simply use the very same graph, né? And answer the next question. The next question is about the volume. It's about the volume. Okay, we will rewrite it. It's no problem. It's about the volume. And here the volume is not what? The volume of ordinary geometrical figures like the volume of a box or the volume of a cylindrical something like this. What is the volume of something like this? It will just be what? The area of this base, because it's circular, therefore it will be pi r squared, then multiplied by the perpendicular height. Then here we're not going to ask you to find the volume of an ordinary standard geometrical features or figures, or like the volume of a box. The volume of a box is just the area of that box, because the area of the box is rectangular like, then it will be L multiplied by B, then multiplied by the perpendicular height. But here we're going to ask you about what? The volume of a solid of revolution. And what is a solid of revolution? As I've said, it will be like this, but let us start with something like this. If you take this, y equal to x squared, say part of it, then say something like this. And then we have got the line here, y equal to 1. In other words, you take the region enclosed between between what or by what? Between y equal to x squared, what here? Y equal to 1 and what? Where x is greater than 0. The region where this y equal to x squared, y equal to 1, and x equal to 0. These are your boundaries. So which region are we talking about here? That is this region. You take this region. You take this region. The top boundary is part of y equal to 1. This y equal to 1. The right boundary is from y equal to is this one, y equal to x squared. What about the left? We are saying it must be what? The region where x is greater than 0, meaning this side, because y equal to x squared is not only this, it will also be this one. But we're saying what? Consider it where x is greater, let's say x greater or equal to 0, so that we include this one. Does it make sense? Now, you take this region and now you spin it, you rotate it. That line of rotation is going to be what is called the axis of rotation. You take this and you rotate it, or you revolve it, or you rotate it, revolve it by the y-axis. You take this, you spin it by this line. What are you going to get? What are you going to get? No. Okay, let me just plug my battery here. They say the battery is low. They say my battery laptop here is low. I don't have a charger. Where somebody took it. Let me just get a charger. I'm sorry, it says what here? My battery is low. Otherwise, it will go off. It's good. Otherwise, it will go off before we know it. Okay, let me just plug it in. Let me charge it. Where is it? Just check. Is it on? No. Let's just plug it in. Ah, perfect. Okay. Now, when you rotate it by this line, by the y-axis, so this y-axis is going to be the center. But now the question is, what are we going to get? We are going to get something like this. I'm not sure whether this is visible. That is called what? In township language, it's called topo. Can you see it? Topo, topo, topo. Is it visible? Can you see
Yes.
it?
Yes, we
Yeah,
can.
it's going to, yeah, that is topo, 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 topo. That is what is called a solid of revolution. But now, this line now, it will be our center. That is the axis of revolution. It will be our center. But if you take something like this, say you have got this, you have got y equal to x squared, like this again, y equal to x squared, and y equal to x. Say this line, y equal to x. Then you take this region and you spin it again by the line by the line x equal to 0, or still by the y-axis. You take this region, you spin it by this line. So what are you going to get? It will still be topo, but then with a hole inside. With a hole inside. Because of this part, because of this part here, because of this part. Because you are going to take this, then it will now be this part is going to give you a hole inside. It's not going to be completely closed. Now, what we are going to do here is we're now going to find the area of this, not the area, the volume of a solid like this. Now, this, it will not be, the formula is pi. The formula is there. It will depend on whether your solid of revolution has a space like this one inside, or it has got no space like this one. It will have no space if this line of rotation is part of the boundaries of your solid. But if this line of rotation is not part of the boundaries of the region that we're spinning, then we're going to get what is called small r. This is small r. And this one here, it will be capital R. Hopefully you understand it. So now, what is the volume here of this? Say this is y equal to x squared, as we have said, and this is y equal to x. We are spinning the region enclosed between these two graphs by what? By, say, the line x equal to 0, or by the y-axis. Or you can spin this again, this region, by this horizontal line. It doesn't matter. The answers, they will just be the same. Not necessarily the same, but the principle is the same. The small r here, if you spin it like this, what will be the small r? If you spin it by this now, you spin in this region. What is the small r? The small r is going to be this. That is, but now because it's a vertical distance, therefore it will be y here minus y here. But if you spin it like this, the small r, it will be, and because it's a horizontal distance, therefore it will be x here minus x here. That is small r. Capital R, it will be x here minus x here. If you spin it by this horizontal line, small r, it will be y here minus y here. Capital R, it will be y here minus y here. Hopefully it makes sense. So let us just say this one then. Say we're spinning it by this line. So it will now be r squared minus r squared, now with respect to x. Then from there, you now look at this region. Where does it start? It starts here. It will continue until the point of intersection here. So then this becomes pi. What is capital R? Capital R is y here minus y here. And what is y here? Because it's y on the line y equal to x. Y at any point here on this line is x. Therefore, it will be x squared minus. Now you say y here on the parabola minus y here. Y here at any parabola is x squared. Y at any point here on the parabola, it will be x squared. Therefore, it will be minus x squared integrate with respect to x. And this is in terms of x. Then you must now say this region, where does it start? What is x there? X here is 0. It will continue and continue until the point of intersection here. And what is x here at the point of intersection? It will just maybe what? You take the two equations, y equal to x and y equal to x squared, then you solve what? You solve simultaneous equation. But looking for what? For only x. Because you are looking for only x. Then it will be x equal to x squared, then it will be x minus x equal to x, then it will be x in brackets, x minus 1 equal to x. 1x is 0, which is this one. Then the other x, it will be x equal to 1. Then you integrate this, then you get the answer. Hopefully that makes sense. Does it make sense? Any question? If nothing, I'm just looking at the time here. Dr. Lamin, what must we do? We still have what? The Modularian series and the matrices.
I think we can continue. We can just continue.
We can continue.
Yes, I think let's just continue and finish with the work, and then they'll ask questions thereafter later on during the week.
Okay, perfect. Okay.
Yes.
Now, the next section is, as I've said, one is about the Modularian series. Then the other one, it will be deal with the matrices. Now, according to this, it looks like your curriculum is only about what? Our curriculum, okay, let me just write the formula for the Modularian series. The formula for the Modularian series is this: n equal to 0 up to infinity. This function here, say what here? A, x minus a up to, that is x minus a, exponent n over what? N factorial. That is the general formula for Modularian series. But it looks like, according to your syllabus, Dr. Tamini can clarify this. Yours is special. Special in the case of that what? That A here is not just an ordinary A, ordinary real number. Your A, it will be 0. Therefore, your Modularian series, then it will be this. Because yours is special. A is 0. Therefore, instead of just a here and x minus a, then it will be this. And if you look at this, the expansion here, it will now be what? You replace n by 0, you get the first term. You replace n by 0, you get a first term. You replace n by 2, get a second term. You replace n by 3, get a third term, so on and so forth. But the formula is there. If you replace n by 0, then it will be just f of x, because n is going to be 0. It will now be n, that is exponent 0, that is evaluated at 0. Then you replace n by 0, then you say 0 factorial. And then from there, because now this is just like this, therefore we don't have to differentiate. Then it will be this. It will be your function evaluated at 0, then x exponent 0 is just 1. Then what is 0 factorial? What is 0 factorial? Okay, we can look at this. Remember, n factorial, we mean this product. Okay, let me just use numbers. Say, what is 9 factorial? 9 factorial, we know it's 9 multiplied by 8 multiplied by 7 multiplied by, until the last factor is 1. Then if you look at this product, is 8 factorial. Therefore, 9 factorial is the same as 9 multiplied by 8 factorial. Or again, if you look at this, you can just say, let me just look at this one. Therefore, 9 factorial, one can see this 9 multiplied by 8 multiplied by 7 factorial, so on and so forth. Therefore, what is n plus 1 factorial? N plus 1 factorial, therefore it will be n plus 1 multiplied by, we say n plus 1 minus 1. Then it will be n factorial. It will be this. Therefore, if you make this the subject of the formula, therefore, what is n factorial? Therefore, n factorial, it will be n plus 1 factorial divided by n plus 1. That is this. It will be this. Then, if you let n be equal to 1 here, if you let n be here, n here, b1, n b1 here in this formula, therefore, it will be 1 factorial is equal to n is 1, don't forget. Then here n is 1, therefore, it will be 2 factorial divided by 2. Which is how much? Which is 1. And that is why we're saying 1 factorial is 1. And what about 0 factorial then? You just let n here be equal to 0. You replace n by 0, you replace n on the other side by 0. Therefore, it will be 0, that it will be n is 0, then it will be 1 factorial divided by what? Divided by 1. And we know 1 factorial is 1. Therefore, 0 factorial is 1. And because 0 factorial is 1, then we don't even have to write it here. Then from there, you can just go on and on. Find T2, find T3, and find T4. T2, it will just simply be the derivative, that is, this is T1. It will now be T1, this is what T1, then this will be T2 now. It will not be this. It will be this over this. Remember, we started at n equal to 0. Then it will now be 1 factorial, so on and so forth. This is how much? This is 1. Then you don't have to worry about it. Then from there, you can go on and on. Find the next term, find the next term. Remember, the first term, you replace n by 0, so on and so forth. Therefore, our function here, it is 2 over 2 minus x. Then they say, find the first 3 terms of the Maclaurin series for this one. Then from there, you just simply come and plug it in here. That is all. So what will be T1? T1 is this one, where you just simply replace x now by 0. Then it becomes this. So it will be T1 here, the Maclaurin series. If f is this, then you just simply come and replace x here by 0, because it's just f of 0. This is f of x. Now, what is f of 0? You just simply come and what? And replace x here by 0. Then the f of 0. Then what about this one? You have to find f of x first, because it's the derivative of f evaluated at 0, then multiplied by x. This is f of x. You find its derivative. Before you find it, you can just rewrite it like this. Rewrite it like this. Then from there, you differentiate it. So it will not be, what will be the derivative of this? The derivative of it will be 2 multiplied by this. Exponent minus 2 multiplied by minus 1. It will be this, the derivative of this. Which is how much? Which is 2 over what? Which is 2 over this. Which is 2 over this. Then from there, that is the derivative. Then you replace x by 0. Therefore, this now becomes what now? You just need to come here and replace x here by 0. Replace x here by 0. And this is simply going to give you what? It's going to give you half, because it will be 4 here. It will be 2 over 4 is half. Therefore, T2, the Taylor series for T2, it will be half multiplied by x. The same thing with T3, where you are now going to replace n by 2. Remember, the first term you replace n by 0. The second term, you replace n by 1. The third term, you replace n by 2. And the third term, it will be the second derivative now of this by what? Over 2 factorial. Don't forget, this was over 0 factorial. This is over 1 factorial. And this will be over 2 factorial. Therefore, because it's a second derivative, then you take the first derivative, which was here, take the first derivative, you differentiate it further, you get a second derivative, and then you replace x there by 0. But don't forget, you have to multiply it by x squared. Don't forget again, you have to divide it by what? By 2 factorial. Then that will give you what? The first 3 terms of this Maclaurin series, given f as 2 over 2 minus x. Any question? Any question? Any question? Can we move on? No question? Okay. Now, the next one is what we call, that is matrices. Matrices. We all know what matrices is, or what matrices are. We don't have to go back there looking at all those terminologies. Let us just simply go straight into those exam type questions. One of them, it will be like this. If you have got this matrix, this is a matrix 2, 1, what? Minus 1 here, 0, and what? 3 and minus 4 here. Then you have got another matrix, that is this one. Let me just write it here, 2, 3, whatever. Let me just write anything. Now the question is, solve for x. X is another matrix. How do you find x? Maybe it's 4 multiplied by A minus 2 multiplied by B. Just solve this x, which is another matrix. How do you get it? You take the first matrix, which is A, you multiply it by 4, then minus what? 2 multiplied by the second matrix. And then this is straightforward. It will be 4 multiplied by 2, 1 here, minus 1 here, 0. Then 3 minus 4, then minus 2 multiplied by this matrix here, which is 2, 3, 1, 7, 6, 7. Then from there, we know how to multiply a matrix by a real number. Here, 4 is going to multiply each entry of this. Then it will be 4 multiplied by 2, 4 multiplied by 1, 4 multiplied by minus 1, 4 multiplied by 0, 4 multiplied by 3, 4 multiplied by minus 4. The same thing here, this minus this 2, you can just say, forget about the minus for a while, take the 2 and multiply it by each entry inside this. And now from there, how to subtract, how to find the difference of 2 matrices? Now you find what? This will be the difference of what? Of the respective entries. That is, this is going to be 8 here, 4 here, minus 4, 0, 12 here, minus 16. And this, the 2 here, it will be 4 here. This is 6, this is 2, this is 14 here, this is 12 here, this is 14. Then from there, it will not be 8 minus 4. It will be this. 8 minus 4 is 4. What is this? 4 minus 6 it will be -2, -4, -2, -6, 0 minus this is -14, 12 minus 12 is 0, -16 minus this, then it will be -30. This matrix is -2b. That is how. Any question? That's fine. Any question? Now the last one, if there is no question, the last one, which according to what I was given, it worth a lot of marks. Somewhere there around 7 marks. Just imagine getting 7 marks out of 50 or whatever. If out of 50, then that 7 marks will translate into 14%, meaning you are already there. Good. Now we know this. We know this. That is 2 multiplied by its reciprocal. 2 multiplied by its reciprocal. What is the reciprocal of 2? Is 1/2. This is going to give you 1. And we know what 1 does to any real number. You take any real number, you multiply it by 1. You get that real number back. Therefore, 1, it will preserve any real number. I'm talking about when it comes to multiplication. Say 3/2. You multiply it by its reciprocal. And in fact, we call it what? It's a reciprocal identity. It will be 2/3. It will give you 1 back. Now, with matrices, unfortunately, what? We cannot find the product of all matrices. We can't find the product of all matrices. But with real numbers, you take any 2 real numbers, you multiply them, you will get an answer. But if the answer is 1, then those 2 real numbers, we call them what? The multiplicative inverse of each other. But unfortunately, with matrices, or the product of 2 matrices is not always defined. The product of 2 matrices is not always defined. Let's say you've got a matrix like this one. Say you have got 2 here, you have got 3 here, you have got 4 here, you have got 5 here. Then you multiply it by this matrix, whatever. Let's say you have got 0 here, 1 here, 4 here, whatever, -2 here, 3 here, and this one. Will the product, can we get the product here? Can we get the product of this? Let's just get another one, say -2 here, 3 here, and -2 here. Can we get, does the product of these 2 exist? Let's see. What are the dimensions of this? This is 2 rows. Remember the dimensions. You start with the number of rows first. It will be how many rows? 2 rows. Multiplied by how many columns? 2 columns. Therefore, this is a 2 by 2 matrix. 2 rows, 2 columns. 2 rows and 2 columns. Now, what about this one now? What are the dimensions of this? How many rows? 1, 2, 3. Then it will be 3 rows and how many columns? 1, 2, 3. 3 columns. Can we multiply these 2? Does the product of these 2 exist? No, it doesn't exist. For the product to exist, the number of columns here must be the same as the number of rows here. The number of columns of the first one must be equal to the number of rows of the second one. If you have got 2 multiplied by 3 here, that is, maybe this one is out. This one is out. Only 2 rows and how many columns? 3 columns. Then the product will exist. And because it exists, therefore it will have a dimension. What will be the dimensions? It will be this and this. The dimensions of the product here, it will have 2 rows and 3 columns. Even if you've got 4 here, meaning if you add another one here, say -7 here and 8, then the product will still exist. Why? Because this one is the same as this one. And what will be the dimension of the product of these 2? It will not be what? 2 by 4. That is this one and this one. Now, take it further to say what? There are what? Say what? When you want to preserve this, say this. You have got this one here. Let's say 2 and 3, 4 and 5, and you multiply it by this, which is called the identity matrix. Why do we call it identity matrix? Because this one, it will preserve any 2 by 2 matrix. If you multiply this by this, product will exist because this is 2 by 2. This is also 2 by 2. Therefore, the product of this will exist. And what will be the product? This we call it the identity matrix, or just simply the unit matrix. It acts like 1. When you multiply any real number by 1, you multiply 4 by 1, the answer will give you 4 back. And this one, because it's an identity matrix, when you multiply it by any 2 by 2 matrix, the answer here, we don't even have to work it. It will be this one. Why? Because this one is an identity matrix. Now, we take it further to say, hopefully we're still together. We take it further to say, there is another matrix. There is another matrix such that when you multiply it by this, it's going to give you this one. Let's say this is A. You call it, let's say it's A. There will be another matrix for this one. There will be another matrix such that when you multiply it by this, it's going to give you this one. That is, let us just call it this A, and let us call it that matrix, which we know it exists. Let's say what? X1 here, X2 here, X3 here, and X4 here, the elements. Such that AB, it will be equal to this. It will be equal to this. If AD exists, then what? We call B the inverse of A. We call B the inverse of A. And we don't use another letter B. We just simply say what? A inverse. If A by B, it gives you this, then A or this is the inverse of this, or this is the inverse of this one. Now the question is, given a matrix like this, how do you find its inverse? I mean, if it exists. Hopefully that makes sense. Given any matrix, but in fact it will be a square matrix. We know what a square matrix is. Given a square matrix, can we find another matrix such that the product of the two will give you an identity matrix? Now, for our question here, or for our purpose here, they say we must take you through the method called the adjoint method. The adjoint method. So let us go through that method. Now, where you will be given a matrix, then you are now asked to find what? Its inverse, using the method called the adjoint method. Do you have a question, Deborah?
Not as yet. Not
Everything
as yet. I'm following.
Everything is. Oh, okay, very good. Now
Yes.
they say this. Let me just read this. Use the adjoint method to determine the inverse of the coefficient matrix given by this. Let me read it again. Use the, remember, we will send you the slides, or just simply the solutions properly. They say use the adjoint method to determine the inverse of the coefficient matrix given by this. You are given this matrix. Let me just write it here, because there will be a lot of calculations. You are given this matrix. It's a 3 by 3 matrix. It will be what? It will be 2 here, 3 here, 1 here. The entries, 0 here, 4 here, 1 here, 3 here, -3 here, and 2. Now, what is the formula for the inverse? Using the adjoint method. The inverse using the adjoint method, it will be the adjoint. We will talk about this. Divide by the determinant of A. The inverse of A, this is A, its inverse, using the adjoint method, it will be given by this. Now the question is, how do you get this numerator? And how do you get this denominator? And as you can see, the denominator here is the determinant of A. Therefore, your first task must be what? To find the determinant of A, and it must not be 0. Because if the determinant of A is 0, therefore, there is no inverse, because this cannot be defined. Therefore, your first task must be what? To find the determinant of A. Given A as this, then what will be its determinant? Because remember with matrix, you use square brackets. With the determinant, you use something like this, the absolute values. Then what will be the determinant? Hopefully, we can all get it, né? The determinant. How do you get the determinant of a 3x3 matrix? You can use any method, né? Yes. So, but now, let us what? Let us use the expansion. Why? Because 1 and 3 here is 0. Therefore, what? We are going to use, remember, with the determinant, you can expand using any row, or you can expand using any column. But preferably, use either a row or a column that has got many 0 entries. Here, there is a 0. Therefore, it's not advisable. Not to say you are wrong, but it's not advisable to use what? To use the first row, to expand using the first row, or to expand using the third row, or to expand using the second column, or to expand using the third column, while there is row 2 here that has got a 0 entry, while there is column 1 here that has got what? A 0 entry. So expand using either the second row or the first column. That will help your work. So let us expand using what? The first column. How do you expand using the first column? You write this, because we are going to use this. We are going to use this, these entries. Then you write this first entry. Then you multiply it by what determinant? You then cover the row that contains these 2. Therefore, you cover the first row. You cover as well what? The column that contains the 2. Therefore, you're going to cover this and you cover this. You cover the first row because 2 is in the first row and the first column. Therefore, you cover the first row and the second, the first row and the first column. Then you are going to be left with what? 4 here, 1 here, minus 3 here, and 0 here, and 2 here. Then what next now? Then we know, then it will be minus. We don't have to go there. Minus what? Then you write this next entry, which is 0. Then what? You cover, because the 0 here is in the first row. No, it's in the first column. Therefore, you cover the first column. Which row? The second column. No, which row? The second row. Then you're going to cover this and this. You cover this and this one. You cover this and this. Then you're going to be left with what? 3, 1, what? Minus 3. And then we don't even have to consider this. Why? Because at the end, we're going to multiply it by 0. At the end, we're going to multiply it by 0. Therefore, there is no need to even talk about it. Because at the end, we're going to multiply it by 0. And that is why we're saying what? Expand using a row or a column that has got many 0 entries. Because imagine if this one was 0 as well. If this one was 0 as well. Therefore, our determinant was going to be what? It was just simply going to be obtained from this one. So, but unfortunately, we have got only 1 0. We are not even going to include it. Then this will be plus 3. Then you find the determinant. Where is 3? Is in the first column. Therefore, you cover the first column. In which row? The third row. Then you cover this and this. Then it will be 3 multiplied by what? This determinant obtained using this. Then from there, you'll get an answer. So what will be the answer? 2 in brackets what? 8 plus 3. This is plus 3 in brackets what? You multiply 3 minus 4. Then what is the answer? This is 11 multiplied by 2. Which is how much? 22 plus what? 3 multiplied by minus 1, which is just how much? Minus 3. So what is the answer? The answer is 19. Therefore, the determinant of this is 19. Then we're going to come and plug it here. Therefore, because the determinant is not 0, therefore, there's an inverse. Therefore, there's an inverse. Then how do you get the inverse now? You are now going to find that adjoint now. Here, it will now be what? The entries of that adjoint now. Remember, after finding the adjoint, then we're now going to transpose it. So how do you find the entries of that adjoint? It will now be something like this. Lot of calculations now. What you do with this one is how much? Now, you cover this again. Remember, the inverse, it must be what? A 3 by 3. So now, how to find the entries of the first row? Thereafter, how to find the entries of the second row? How to find the entries of the third row? And thereafter, you transpose it. Hopefully that makes sense. We must now find the entries of the first row. How to find it? You expand using the first row. How to find the entries of the second row? You expand along using the second row. How to find the entries in the third row? You expand using the third row. From there, you are going to transpose it. Now, let's go now. Find the entries of the first row. How do you find the entries of the first row? You cover, then you cover. Then it will be the determinant of 4, 1, minus 3, and 2. Does it make sense? Then you say minus. We are still busy with the entries of the first row of the matrix that we are going to transpose. Then what? This is going to give you the entry of the first row. This determinant is going to give you the entry of the first row. What about the entry of the second row? You say minus what now? Now you cover this, and you cover this. When you cover this, what will be left is 0, 1 here, 3 here, and 2. This is going to give you the entry of that is the second entry in the first row. Now from there, plus what? You do the same. You cover this, because now we want something corresponding to this. You cover this. Then it will be 0, 4, 3, minus 3. Now, next. Let's say this is equal to here. Next. It will now be what? You cover here, because we are now going to the second row now. You cover the second row. You cover the first row. Then this is minus, because this was plus, then it will be minus. You cover this. It will be 3, 1, minus 3, 2. Then it will now be plus. Plus what now? You cover this, and you cover this. You cover this. Then it will be 2, 1 here, 3, and 2. Plus, then it will be minus. Then what now? Then you cover this, because you are still busy with the second row. You cover everything in the second row, you cover everything in the third column, because 1 is in a good. You cover, then it will be 2, 3 here, 3, and minus 3. Then from there, this is minus, this is plus. We are now busy with the entries of the third row. Then it will be how much here? You cover this. Then it will be 3 here, 4, 1. From there is minus. From there, you cover this. That is this one and this one. Then it will be 2, 1 here, 0, and 1. Then it will be plus. Plus what now? You cover this. Where are we? Now you cover this. Yes, you cover this. Cover this. It will be 2, 3 here. Cover this. 0, 4. Now, this is going to be, it's going to give you the entries of that matrix that we have to transpose. Then, what is this now? It will now be what? 8 plus 3. This multiplied by this, the determinant of a 2 by 2. This is 8 minus the product of these two. The product of these two is minus 3. Therefore, it will be 8 minus negative 3, which will be 8 plus 3 is 11. Now, what about this one here? It will be 0 minus 3. which is minus 3. Minus 3 multiplied by this, then it will be 3. Now this, it will be 0. That is minus 12. Therefore, it will be minus 12. Then next, what about this? Don't forget the minus. It will be 6 plus 3, because it will be 6 minus negative 3. Therefore, it will be 6 plus 3. 6 plus 3 is 9. Minus multiplied by this is minus 9. Let us just squeeze it here. What about this? It will be 4 minus 3, be 1. Then this, don't forget the minus. It will be minus 6 minus 9. Minus 6 minus 9 is minus 15. Minus 15 in this, it will be 15. Please correct me if I'm getting something wrong here. Then this is 3 minus 4. 3 minus 4 is minus 1. Then this minus here, this is 2 minus 0. Then it will be minus 2 here. Now this is 8. Then it will just be 8. And what is this? This is that matrix that we must now adjoin now. This is a matrix that must be adjoined. So therefore, what will be the adjoint of this? No. What is the transpose of this? This is the matrix that we must now transpose now. It will be A exponent T, the matrix that we must now transpose. By transpose, we know what we mean. In transposing a matrix, what? You just simply swap what? The rows and the columns. What was the first row? It will not be the first column. What was the second row? It will not be the second column. What was the third row? It will not be the third column. I'm talking about what? The entries. The entries of the first row will now be the entries of the first column. Therefore, it will not be 11 here, 3 here, and minus 12. These entries in the second row will now be what? The entries of the second column, which will now be minus 9 here, 1 here, and 15. That is A exponent T. That is the transpose. These entries of the third row, it will not be what? The entries of the third column. It will not be minus 1 here, minus 2 here, and 8. That's good. And we're now done. Why? Because what is the inverse now? The inverse of A. It will now be this matrix, that is the adjoint, divided by the determinant of A. Or simply this matrix multiplied by the reciprocal of the determinant. Because we are now going to take this and plug it here. Then you multiply it by what? 1 over 19. You just have to finish it now. Because definitely it's very simple now. You just, because this is this now. You just have to do it now. Any question thus far? Don't forget to finish it. Don't forget to finish it. Any question? Any question? This is just AT, which is just the adjoint. This is the inverse of this. And in this context is this one. Don't forget, this is the transpose of this. In this context, it will be the adjoint of this. Any question? I think that is the last one. That is the last one. And from what I've seen, this is worth about 7 marks. Therefore, you must make sure that you practice. But definitely just straightforward. It's just straightforward. Then if you have a calculator, you can just keep on double checking. Like what the determinant, you can just calculate the determinant using a calculator. But remember, the calculator is just simply to verify. Get the determinant manually like this. Then to verify, to check whether you have got the correct answer here, you didn't make any mistake, then that is where you can use your calculator. Don't use a calculator straightforward, because definitely your lecture want to see your calculations, whether you understand it. Now, calculator, you can just use it to verify. Unfortunately, as far as I know, the calculator cannot give you what? The adjoint. It can't give you. I mean, from what I've seen, from those that I know, this world is moving fast. Maybe I will say there is no calculator. I want to find that they've already invented one. Any question? I think this is where I think my part comes to an end. This is the end of my part. Unless if there is a question. Any question? But don't forget, you can still ask me a question even after this session. You can just simply email Dr. Dlamini then she will forward it to me. Then I will be happy to answer you. I can even what? Call you via WhatsApp and then try to explain whatever. There's no problem. Any question? Any hand? Any hand? Do you have a question? Yes, Siga?
Do you have any other advice for us besides what you've shown us today? Or anything else that we should be paying attention to just in case?
I think Dr. Dlamini is the most appropriate person who can answer that. With me, I was just asked to come and go through these topics with you.
Okay, that's fine.
Or
Just a
Dlamini?
quick question. Just a quick question on the one example here where you've got on this matrix C where you got the 15. I kind of got lost just a little on the 15 part because I know you said it's going to be 2 by 3, which is 6, but there's a negative sign there. That's a -6. And then the minus and the minus
-6
becomes a
minus
plus.
9.
Yeah,
Did you get it
then,
this one? Did you get it this one?
yes, I understood that. I was
Did
just
you get it a
how
3?
you got.
How did we get a 3?
So you
How did we get
essentially
a
went
3? We said
0 and 2 is
0
0,
multiplied by 2,
is
which is
0.
0,
And the 1
minus
is
3.
my.
1
Oh,
by
that's where
3
I
is
lost
3.
myself. Sorry.
So it will be 0 minus 3, which is minus 3. That minus 3 multiplied by this one.
That
The same
is
thing
because I
with
forgot.
this one, the same thing with this one.
Yeah.
Yeah, it's the same.
Yeah, I left
It
the
will
minus
be
out. Sorry.
2 multiplied by this. Yeah, it's minus
Yeah,
6, minus
and
6
then minus
minus
again.
9. It will be
And then the
minus
minus.
15. That is why I kept on saying, don't forget this minus. Don't forget this minus. Because once you forget the minus, then you are out. You will never come back.
Yeah.
But now,
Yeah.
if you still have time, don't forget, if you still have time, how do you check the correctness of this? Because how do you check the correctness of the final answer? The inverse. Because we say the inverse, it will now be this multiplied by 1 over the determinant. Then you get the inverse. How do you verify the correctness of your inverse? You take the A, don't forget, A multiplied by this, it must give you the identity. That is A multiplied by its inverse. It must give you what? 1, 0, 0, 0, 1, 0, 0, 0, 1. If it does the product, if it doesn't give you this, then you must know that your inverse is wrong. Meaning somewhere, somehow, you made an error. Another question is, will you have time in the exam to verify all these long calculations? The answer is, I doubt. So the best thing is what? Just make sure that you focus. No mistake. Focus. Make no mistake. If you focus, you understand it in focus, and then you get everything that's great. And that is what I'm saying. What? Sometimes, supplement this with a calculator, just like the determinant, because a calculator can get your determinant. Then after getting it manually, then check it using a calculator. So on and so forth. Any question? Any other question?
Thank you, Mr. Sulane. I think there was a second question, which then was redirected to me on. Would you please repeat the second question before I just answer? You said the student who just
the SIGA wanted to find out whether there are any advice tips that I can give to them.
Yes, that was just
looking forward.
That was that.
Okay, so for me, I think from my side is make sure you understand your work, right? So when you're given a question, especially with the whole integration and differentiation, you need to be able to also use the formula. For me, I normally use the system of how, when, and why. How are you going to apply it? Why are you going to apply it? And when you are going to apply it? Because if then you look at the question, you should be able to say, okay, fine, this looks like, what's this? This looks like a certain formula from the the formula sheet. So if you are able to use those formulas and understand when to do a particular question, that's easier. Because I notice most of our students, what they do is they just keep on practicing questions and not understanding them, and then it becomes hard for them to go into the exam. When they get into the exam and they don't find a question that is similar to what they've done, then it becomes frustrating. So if you understand your work and you understand all the steps, I think that will really help, right? Because then Mr. Kune and Mr. Silwane, they actually highlighted. If you notice, they were highlighting when to. So those are the small things that you need to make sure you focus into, not practicing a lot of questions, thinking that at some point you will get it. First, understand the concept. After understanding the concept, then you go and apply the concept, and then you can come back and redo this this question paper. And if you have any questions regarding the work, you can always come back to us and send us an email. So for now, while we are waiting, because they say that the exam will be, the special exams will be between the 10th and the 24th. So they haven't given me, I think 20th, sorry. So they haven't given me the exact date. But from now, from today upwards until you are given the date, you can send us an email. If you don't understand the concept, even though it was explained, you can always come back to us and then send us an email, and then we'll help you. And while you're also practicing, send us an email. We'll be able to help you. Okay.
Thank you for
Any
that.
other
I do
question?
appreciate it. I'm good.
Okay, still on the exam. I noticed that that formula sheet. Remember, Dr. Dlamini, that example that you gave us, it has got formula sheet attached at the back. But I've noticed that there is no formula for the area.
Yes.
There is no
Yes.
formula for the volume of solid of revolution. I'm not sure whether it was edited or thereafter during the exam or what.
Okay. What's yes. Okay. So now, would you please send me an email, Mr. Swane, so that we can actually fix that? Remember that I took over this module, so I'm not aware which formulas are not there in the in the formula sheet. Because right now, currently, when I prepare work, I prepare based on the formulas that are already in the study guide, and those formulas I also find in the study guide. But then in the exam, I wasn't aware, because Mr. Kune made me aware that there's actually some formulas that are not that particular, on that particular cheat sheet. So what we'll do is, please send me an email, and then we can, just a reminder, so that we can, before they actually get the exam, we can then just go and copy from the study guide and then include them. Thank you.
Okay, I will do that, dear doc. Even with me, I just saw it when I was looking at the question and say which formula here, and then I noticed that no, some of the formulas here, especially that of the area, finding the area between two caps and finding the volume of the solid of revolution, I realized that no, they are not there at all. And I'm not sure whether which method, because here it looks like I've used only the washer method, but we still have the shell method. So I'm not sure whether the curriculum requires only one method or the other two methods, or even finding the inverse. Remember, with the inverse, yes, I only used one approach, that is using the adjournment, or you can add a method, it will be adjoining, just adding the identity matrix to the given matrix, and now from there doing those algebraic operations until the two have swapped. I'm not sure whether that should be included as well or what.
I think at the end of the day, for me, I would say we'll have to go back to the tutorial later, as well as the module form. I will have to go back there, because at the end of the day, we need to cover for what is what must be covered for the engineers. So I don't want us to go then uprooting into above their scope and go to the mathematical parts and say we cover this. So what I'll do is I'll go to the tutorial letter as well as the module form and see if we then have to cover the other methods. If not, but we then have to end there. But I think when it comes to, as you said, when it comes to the whole application of integrations, I think that in the is covered. So we'll have to maybe find time and just give a short recording before they actually write the exam. Mr. Swane, is that clear? Or
Yeah,
can you hear me?
very clear. I will only
Yes.
email you the formula that is needed for what you have shown me as exam type questions. Yeah, that's right. The others maybe will.
Okay, you cut them.
No, I was saying, I
Yes.
will only give you the formula that are needed based on what you have said. It will be exam type questions. Then the other formula, no, we'll discuss them later. Yeah.
Yes, I think we have to, at the end of the day, we'll have to go back to and check if the other things are, so the what's this, the module form will then redirect us on where to end, as well as the study guide. So we'll go back there and just have a look. Maybe we can have a discussion tomorrow. I'll just send an email tomorrow then. Maybe we can have a discussion on that one.
Perfect, and done from my side, unless if there is still another question.
Any other question from our students?
Yes, Deborah.
Any other questions from our students? Guys, you don't have questions.
Hello, ma'am.
No, Deborah is asking something.
Yes,
I think Mr. Swane, there's no question from a student.
No, Deborah's hand is up. She's trying to ask something. Yes, go ahead, Deborah.
Okay, I was asking concerning the date of the exam. The thing is, people like us who are in the rural areas, we normally try to. Can you hear me? Can you hear me, Dr. Damini? Yes, I was saying people like us who are in the rural areas, we normally try to get to places where the network is not easily interrupted, because now the issue of this load shedding has actually messed a lot of us up. Now,